my name is Andy Jing, and I'm currently a junior at Jericho High School. And today we'll be taking a look at our pre-algebra lesson for evaluating variable expressions with the skill substitution. So to start off, what exactly is a variable? Well, variables are something that we use to represent a number or a value that we don't know yet, or a number that could also be changing. So what would be an example of that? Well, if you were to count the number of birds outside chirping right now, and let's say you get a number 3 out of 4, that number may very well change depending on the time of day. So at night, the number will probably be lower. So to account for that, we can use what we call our variables, such as x, y, p, a, or any letter or symbol that simply represents the variable or unknown value or number that we don't know yet. Well, so what would be a skill that we can utilize to plug in these values when we're solving expressions? Well, to start off as an easy example, let's not even start with a variable yet, or a letter yet. Let's say this blank, this underline, represents a variable. Well, if we were to plug in or substitute any number, we could get, let's say we substitute 2 and a b, sorry, excuse me for the poor handwriting, but we could have 1 plus 2, and in that instance, it'd be 3. So if we had 2 birds outside, in which we represent here, and then we added that to our 1 here as part of the equation, we'd get 3. And let's say, since variables, as we explained, can change, we had later just 1 bird outside, so we get a 1. So plug into whatever equation we have here, 1 plus our variable, which is 1, then it'd be 2. So as you can see, as variables change, that's why the products or sums of our evaluated expressions or equations could also change. So let's hop into some examples. So first off, we're given here that x equals 2. So we know that x just simply stands for a variable, and we know that 2 is the value that they're giving us for. So outside of this problem, we may not know what x is, so that's why we use x to represent an unknown value. But here, since they give us x equals 2 in just this context, we can just plug in 2, because x equals 2 here. So 2 plus 2, well, that's 4. Excuse my poor handwriting. Let's try again. So, same concept, but here, there's another important thing to take note of. Our variable, or unknown number here, a, is equal to 17 in this context. However, here it's written as 2a. So, an important lesson and an essential notation to keep in mind is that when we have a variable and we're multiplying with what we call a coefficient or a constant number, we actually don't have or don't use a multiplication sign. Instead, we simply put our variable or symbol, which is a in this situation, right next to our coefficient, and that's simply the notation that we use for multiplication. So now that we know it's 2 times our symbol here, a, and keep in mind that a variable can be any letter or symbol, then we know that it could be 2 times, well, we plug in our value that we're given for a here, 17, 2 times 17. And you could do the long multiplication if you want. And I'll give you a second, but that will come out to 34. And do not worry if you cannot do the 17 times 2 right away. We're here just to practice the subbing in, or substitution skill, as we mentioned. So, just to review, since we have a number given for our a variable, 17, we plug that into the equation 2a, or 2 times a. And another small term we can use to call this is also a monomial, because we simply have one unit in this, one term or unit, or maybe just object in this equation. So mono is simply shorthand for 1, so we have monomial. And here's another more tricky example. So here we actually have 2 variables, x and y, and these are probably if you were to choose two variables, these would probably be the most common ones that you'd see. So what happens when we have two variables? Well, it's the same concept and the same skill as, again, substitution or plugging in these numbers. So they give us that in this situation, x equals 2 and y equals 3. So we simply, again, plug in now this time both of our variables. So we'd have 3, and again, since they're next to each other, this just means they're being multiplied. So 3 times 2, and then we'll be adding that to, let's see, 2y. And again, that'd be the same thing as 2 times y. So what would be 2 times y here? Sorry if my y here looks like an x, but 2 times y, and remember that we're given is y equals 3. So it'd be 2 times 3, which we can put down here as well. And then simply we have a plus 1. And how do we know to do it in this order, even though it just happened to go left and right in this situation? Well, if you remember our order of operations unit, that we simply know that since this is multiplication and the m for our multiplication, PEMDAS, comes before our addition, we simply do our multiplication first. So we'd have 3 times 2, which is 6, 2 times 3, 6, and what's left over is our plus signs. So since they're both plus signs or equals, we can do whatever order thanks to the commutative property, but we'd get 13. So just as a reminder, even with two variables, if we're given the set value for both of them, we simply plug in both of them. And our last example here is simply the same concept, even if it may look a little more scary. So here again, we have three variables. And this time we're using A, B, and C, because again, for the last time, we can use any letter or symbol to represent a variable. That's the beauty of it. When you're making your own when you're evaluating your own expressions or making your own equations, you can use any variable you want. So here we're given that A equals 8, B equals 2, and C equals 10. So let's take a look at the expression that they're giving us. Well, we have 2 and in parentheses, so that'd be 2 times in these parentheses, A plus 2B plus C, and then out of parentheses, minus a 2C. So here's a good practice of our order operations or PEMDAS. So as we know, that we have to evaluate what's in the parentheses first. So again, since we have values for all of our variables here, we just plug in. So we get 2, since we're not doing anything with it yet, and we're going to evaluate the inside of this parentheses. So 2 times, let's see, we have A, which is 8, 2, again, times B, which would be 2 times 2, which is 4. And then we're going to add it to C. And what's C here? Well, they give it that C is just 10. So plus 10. And then we can fill in the rest here. Just carry over everything else that we haven't touched yet. So we get 2 times 8 plus 4 plus 10 in parentheses. So using PEMDAS, we know that we have to evaluate what's in the parentheses first. So that'd be 8 plus 4, 12, plus 10, which would be 22. So we get 2 in parentheses, or times 22. Sorry if my 2 looks like 7, minus 2C. And again, we can plug in our C here, which is still 10. So that could be also 20. So I'm going to wipe this and just rewrite it. We have 2 times 22. And then we'll be plugging in our 10 for our C. So that'd be 2 times 10, which would be 20. And then, using PEMDAS, we know to do the multiplication first on both sides. So 2 times 22 would be 44. and then minus 2 times 10, which would be 20. And we get 24. And that's it. It might be lengthier, but it boils down to the same skill of substitution and understanding that with a variable, we simply just plug in whatever they're giving us. And thanks for watching. If you have any questions, feedback, or constructive criticism, please shoot me an email at anyjang02@gmail.com, and I'd be happy to respond. Thank you.